Hello everyone and welcome to Iron Middle, a show where we battle technical glitches once in a while, like today, but it seems like we managed to start just 15 minutes late and we are live. Let me check that I can see myself. Yes, I actually can see myself. Okay, so that means that we are ready to roll and we'll get back to what we usually do here on Iron Middle, which is discussing how to implement one of the most exciting database of today, like the database which is like a trailblazer in its specific domain, a database which is implemented with unimaginable amount of craft, and that is DuckDB. Well, joke. No, we are of course going to discuss Iron Middle, and as a reminder. And as a reminder for myself, is actually I honestly don't remember what we have been doing before, but I think let me check. I think we were drawing some diagrams about handling queries, and it looks like Excalibur lost my diagrams, which is slightly unfortunate. Okay, so no diagrams, just me hand waving. So basically, for the past few episodes, we were discussing how Tagabidal query engine works. Tagabidal is an online transaction processing system. So the primary goal of the system is to ingest data as quickly as possible while maintaining the strictest possible consistency guarantees that the data is like fully consistent, that the data is strictly serializable. But after you have ingested the data, you obviously want to get the data back. And the trivial way to get the data back is like, point lookups, give me a particular account, give me a particular transfer. But we also support right now like rather limited forms of queries where you can say, hey, I want to see a subset of transfers with a particular conditions on various fields. Like for example, I want to see transfers which have this particular account ID as either debit account ID or credit account ID. So I think we've covered most of the things. And last time we were diving really deep into the implementation of zigzag merge iterator, which I think we understood well enough, and we even managed to suggest a couple of simplifications. We submitted a pull request. But as it turned out, that pull request was incorrect. Raphael quickly spotted an error And that means that today we are going to do our homework. We are going to actually properly understand the bit of code which we are trying to refactor and see what's going on there. Okay, so oh no, this is not what I want to share. Okay, I was just going to apologize for a technical glitch and immediately went to a different technical glitch where I shared on screen. I'm bad at streaming. I'm only half good at writing code. Okay, so let's see where we are. So I believe we were zigzag merge iterator type. Yeah, we were in the zigzag merge iterator type, and we were refactoring the pk function. And I was saying that, hey, we have like this proben bit set, and we reset proben bit set on every iteration. And that means that when we are trying to modify proben bit set here, at the end of the iteration, that's actually like dead code. Like we can comment out this unset and we can comment out this unset because, well, we're going to initialize it to empty anyway. That turned out to be incorrect because notice that this proben bit set is actually declared outside of this loop. And the loop condition is that we kind of like count the number of bits there. So actually what this is saying is something like this. So we initialize proben bit set to empty. In the first loop inside this loop, we fill it. In the second loop inside this loop, we drain it. And then we say something like if proben count is equal 0, and we break out of this loop. So yeah, like just simple stupid mistake of me like not reading the code, but I mean, you know, if anyone made these mistakes, not just for me, that means that, hey, probably the code isn't obvious, probably the code isn't clear enough, and maybe it could be improved. And then if you let's look at this shape, there is a problem here. And the problem here is that it's not syntactically obvious that this loop actually terminates. Like maybe proben is, you know, ends up always being full or something. So, and in our target style, yeah, we say that, hey, all loops and all queues must have a fixed upper bound to prevent infinite loops or tail latency spikes. But we kind of like violate this here. We don't have like an explicit upper bound on this. So what I want to do today is actually to rewrite this, to understand better what it is actually doing and try to find a more direct way to express this. Okay, so as a reminder, this loop is looping two operations. It is looping stream peak and then stream probe. So stream peak looks at the current key, and stream probe asks the stream to skip the keys until the given key. Now, the thing is, the streams are not in-memory streams. The streams are actually on disk streams. And that means that when we try to look at the element of a stream, we might actually get one of the three results. We might say, hey, the stream is empty, or we might get, hey, the stream is not empty and this is your key, or we might get results saying like, hey, we do not know whether the stream is empty or not. The stream is drained, and you actually need to do some asynchronous disk input output to get the data out of disk. So I think like we have like this multiple streams, and we are interested in finding keys which present in all of the streams. So the general strategy is like, if you have two streams and they do not match, then you know that, hey, you actually need to go and move at least one of them ahead. So essentially, you just kind of like, so basically this drain variant is a tri-modal logic. You might say, hey, there is definitely a match, there is definitely a mismatch, or you might not know. And the thing is that if we know that there is definitely a mismatch, then we want to skip ahead. So I think our logic should be is that as long as we have at least two streams where we could actually pick the keys, we should go and move those streams ahead. And it is only when we get all streams to drain state that we want to do stream pick. But honestly, I'm kind of like unsure here. So I want to better understand what stream pick and stream probe operations actually do. So let's see. As we refilled before calling pick again returns empty if the stream was fully consumed and reached its end. Okay, stream probe probes the stream identifying because I need to move to the next value such that value key is at least probe key assignment. Should not be called if the current key already matches the probe. The stream may become empty or drained after probing. Okay, so this kind of like feels, it should be relatively simple, right? So as John Carmack advised us, when you want to refactor, you don't want to refactor in place. You actually want to write a second version of the code alongside, and then refer to the old code. So let's do this. Okay. So we have our streams, we have key mean, we have drain value. Maybe we don't need drain. I don't really like the name of probe key, so let's call just frontier. So like frontier is kind of like what we like trying to get. Okay, and essentially what we want is two like while loops. One we have like pick until everything's drained, and then we want probe. Oh, okay, maybe it's not the case. Like why are we not doing picking and probing in a lockstep? So Well, okay, let's just do this. So like we are going to iterate all the streams. And we're just going to say, okay, let's pick the stream and if any stream is empty, then we can immediately return null. If the stream is drained, well, we'll figure this out. Now, okay, there are like two cases. Well, actually, I mean, do I want to pick first? I kind of like I actually want to maybe drain to immediately why do I need like two operations? Like actually, it's sort of like, you know, I want to say that something like stream big max k at least. And here I say it context and cast index. That's okay, okay. Do I want to catch with some errors? Which, so it could be empty. Matching overshoot or drained. So these are the four cases. We kind of like try to advance the string one by one. Okay, let's call it poke. Like, no, we are poking the stream to get up to at least that key. Okay, so probably need to. What's the signature for stream? Probe context index of a stream key. Okay. So we're going frontier, and we say const my count u32 equals 0. So if we get to empty, we can immediately return null. If we get matching, we can set match count plus equal 1. Whenever we overshoot, we get a different key. We say that frontier is now equal to key. frontier is now equal to, well, we also assert that e ahead that x, e ahead e before frontier e after. Okay, and we say that match count is equal to 1. Okay, so drain count. And we also, I guess, maintain drain count. So use count, and then drain count, and then if match count, and I guess there's some should also be less, and then we say if drain count equals drains count, we return drained, and if match count is equals names count, we return frontier. So this is actually what we want to do here, I think. Okay, people are complaining that we use light editor thing. Let's switch to dark theme. And yes, sorry about that. I usually, I do use light editor because I'm in Portugal and there is sun, and why would I use dark editor theme if I'm no longer in Petersburg? But yeah, I understand that like for streams, actually people do prefer dark theme, but I do have a lovely dark theme, so let's switch to that. Okay. Well, you're not complaining, but actually I do like this dark theme more. It's that I use light theme because, like, the sun just makes dark theme impossible. So I actually do prefer using dark theme myself when the light allows me. Well, I have some non-transitive preferences. Anyway, okay. So this feels to me like what actually should be happening here. Like we shouldn't like do separate. Well, actually, okay. I think we can actually define a string poke now. String poke. What is the signatures for? It's going to be essentially this one. So then string poke prop key, and it's going to return as a union and of empty. It is exhausted, no more values. Match. Next. Peak will return exactly. Then match. Do I need to change this overshoot batch. I'm missing a good word here. It's not a match, it's like mismatch, overshoot. Oh, overshoot, let's call it overshoot. There's no K in stream, but here's the next best one. And then drained. True negative, true positive. Okay, no, I don't know. Drained. I'm sure got to read some from this to figure out. And this is how we are going to implement this. Poke. So I think we don't need context here. We need just, oh, actually, well, why not? Context is fine. So empty, turn empty, drained, turn drained. If P equals okay, next. Okay, let's call this target. If key equals target, return match. Assert direction. Is direction a contain parameter? No, it's not a contain parameter. Okay, so we actually need the full Zag merge iterator, and then we need context here. Okay, key ahead. I don't really like this. Oh, maybe I like it. Key before. So target key after key. Return. Well, ahead. Empty match ahead. Drain. There we go. Okay, so this is, I think, a function which helps us to wait, no. Okay, after we did this, oh, okay. We can't assert this because we might be like below the target or after the target. And if we're below the target, we actually should then probe. If key ahead, then we return ahead. And otherwise, we are going to string probe and that's also, well, string probe is a void function, right? Yeah, so we do string probe, and then we do this again. So we probed it for target. And here we can assert actually that it is key ahead case. Okay, so this is ugly because we call peek and then probe and then peek again. But I think that's actually what we are doing in this loop essentially. And that is what makes everything complicated. So we just say it string probe. String count, string index. Green count. Well, let's call it green. So this is ahead, match, drain, green, wait, blocked, no, no. Oh, let's call it drain for symmetry. Yeah, I think that makes sense to me because it kind of like feels simpler. And yeah, then we like don't need like this whole. I'm wondering like why. It was written in like super complicated way because it feels like it could be like much simpler. Okay, let's reset this logic exactly. So okay, we do string peek, and then we say okay, we want to probe this, so we kind of like try to peek every single string. Once we did it, we go and we try to probe, and then we kind of like double check afterwards we go okay, so this is just, we double check that, hey, the streams remain drained. Otherwise, we see that, hey, they are all at probe key. Okay. Okay, this kind of like seems simpler. Pop, reset. Okay, let's see what functions do we have here. Reset, probe, poke, peak. Okay. Oh, thank you very much, Morning Sci-Fi, for the compliment. And by the way, I'm not sure if you might be by any chance in Lisbon, but I'm going to do a short talk here in Lisbon. So if you are anywhere around, then please say hello. Let me actually quickly plug this in. Yeah. So we have this event cooking up, and no, definitely not London, definitely not London, Lisbon. Lisbon is where I mean, it's not going to like, you know, big talk or anything. It's like basically like an episode of like Iron Beetle. But well, I will be there. Okay, so okay, that distracted me. Okay, so I kind of like, yeah, I kind of like feel that, hey, we actually could make this that simple. I really do feel like the key number 2 is like way, can I say unfold? Well, it unfolds everything, not just selection. Bad editor, I should go back to emails. Well, anyway, yeah. I feel okay. Okay, so my next question is like, so the problem with this implementation is that now this string poke abstraction is kind of like ugly again, because we like do peek, probe, and peek, and it feels like it might do multiple redundant actions. So I would really love to maybe say that let's just pass in string poke into zigzag merge iterator type. But before we do that, I actually want to double check like what is the complexity. So basically, I don't have a mental model right now, like just how costly are string pop and string probe. Like, should we avoid calling those functions, or is everything cached in memory? And yeah, I really should have been reading those references, but well, no, can't do everything. Okay, so I'm not really interested in test context. I'm interested in the real thing. So scan merge. In scan merge, we pass string peek and string probe. String peek and string probe. Okay, so this is streams. And who are the streams? The streams are and right? So how does peek works? We call scan next. So peek is actually, yeah, peek is like really, really fast. Probe scan probe. Wait, why it only supports, I hate this snap. Why it only supports okay, so that is like the adapter, and that is the whole thing. And what is probe? So I kind of like want to replace like probe with just poke, so that it also turns evading. And what is the scan? There is next, and there is probe. Okay. And okay, it all feels like so very complicated. Wonder if we could. Okay, so who is the scan actually? Like who is the scan here? I'm not seeing the scan tree type. Okay. Read again. Probe. Okay. So this is maybe why we make the API of that shape, because like when you are implementing the scan, you don't really want to cache anything in memory. Okay, we have like merges radio inside, but that merge is like merge. Oh, God, it's complicated. Probe. So what actually, okay, so what do we actually do in a probe for a tree? So like, remember, like why this is like so complicated? This is where like I need the diagram, which used to be in Excalibur drawing, is no longer there for whatever reason. So we have LSM3 on disk. LSM3 is comprised of like multiple layers, and the layers have strict precedence. So if the key is available on this upper layer, it actually shadows everything that is below. So the way we are reading items from an LSM3 is that we scan each layer left to right, and then we kind of like also merge those results. So like the next key might be from whatever layer, and it might even be the case that the key is present in two layers at the same time, and if that is true, we should pick the earliest layer. Okay. I really don't like how we also like much on this like ascendant descendant here. It feels like it all should be abstracted away into like some comparisons. Okay, so maybe actually probe is a reasonable interface for this layer, and that means that that poke function is actually justified. Because yeah, it's just kind of like much easier to write a void function here, because then you don't have to do a merge there. Okay, so let's see with our poke function. So the next thing I'm wondering is that are we losing efficiency here? So, but okay, so I guess string pick is like super fast. So it's no problem to call string pick twice. And well, we're calling string pick twice here, but that's not a problem. So okay, this is good. It feels like that might actually be a simpler way to do this. Okay, I kind of like it. Empty. Best key. Just to figure out. Okay, so I kind of like this. Yeah, we like loop until we either everything has matched or if everything has drained. And if it's not the case, we just continue poking until we get our result. Okay, so this. Okay, well, now there is one more case here is that, okay, so this is actually if match count plus drain count equals its streams count. Everything is either matching or drained. Okay, if match count ring count equals 0. Else, maybe match count greater than 0. Oh, we don't. Oh, we need maybe here. Sorry. Okay. Yeah. So this kind of like looks more like it to me. I really hate this. This is flipped. Key before, key before, key after. Okay, this is. Well, I'm willing to keep that API in the same. Okay, so am I brave enough to actually suggest this as a pull request? Obviously, we need like comments and asserts and everything else. Wow. Well, no, because I actually want to like figure out like this while true. This really should be for upper bound. Okay, let's think about what is going to be like the worst possible case here. I guess it is like this. So we have like stream, like, so let's say we have like 3 streams, right? So we have like 1 here, 2 here, 3 here, 4 here, 5 here, 6 here, 7, 8, 9. So again, like we really could, like worst case, we could look at every single value that is in memory. And that times the number of streams. Do we have this upper bound, I wonder? We don't really have these upper bounds. Okay, so this is good, but that one's not good. This really sadly is a while true thing. Okay, this is. Yeah, we also kind of like should have something like stream values until drained or something. Frontier. This doesn't really have to be key min, I think, because we could initialize previous. Okay, I kind of like do like this, but yeah, I'm not super happy here. Can we write this in some way which is like supervised? Because what I also don't like is that, so here we return drained, right? But in this scan tree, we return read again. And yeah, like, like we have like this read again to drained, and then we have this error empty. So I don't really love it. What would be like, okay, so how would we write the ideal iteration? So kind of like, I guess fn next is going to return a null value or error need read need data. So kind of like I don't like drain, because drain is like synonym to empty, and here is like just unknown. Well, maybe we could just say this, hey, like unknown. No, it's a bad name. Error exhausted. Error refill. Spent empty. Need read. Would block. Yeah. This actually it really is like would block error, and I think yeah, and we call this pending. Okay, so this is it. So then if we do string poke, I'm just trying to figure out like what is the best way to model this in terms of types. So let's actually say pending error pending. Okay, so we might say pending, or this is it. I think it starts to come together. So we poke a string, and we either say sorry, we need to read more data, nothing else, or we say sorry, our string is exhausted, you are never going to get this target, or we say, hey, we got this key, which might be equal to your target, or it might be ahead. Okay, let's see. Then we say just try string peak. Like I assume that all other have the same interface. So poll. What is Rust's poll? Is it pending in Rust poll? Like the name of the variant. I'm trying to understand if this is the same thing. Yeah, pendant. Okay, yeah. Okay, so I get. Okay, I think I got it. I think I got it. Okay. Uh, if we get pendant, we just like no throw it away because we know hey we have pendant. That's kind of like we can short circuit short circuit here. Or else return now. So we short circuit both the try thing and the now thing. Otherwise, we have key and if key equals target or key ahead, we return it. And okay, so technically, this will force the parent to do another comparison of the keys, but I think this is maybe fine. Like after inlining, like the compiler should see through all this trickery. Okay. Then we do string probe. Then we do another. Return. And we can assert that key equal target or key ahead. Okay, yeah. So actually, okay, haha. I think this is going to be like massive simplification. So can I format this if in the same way? No. Kind of like how it aligns here, but you can't really do this here. Well, it doesn't really matter, I guess. So I do like that version of the string probe more. And then if I pick the key, I just say okay. So I do catch error switch and then so then we say that pendant count is larger. And we continue. Otherwise, if e equal, and here we say count plus equal 1, else match count equal 1 here is equal to k. So this also would then return pending or key. Okay, yeah, I think this is going to be our canonical signature here. I'll wonder, can we like it could also be like this, but I think this one is probably better. Okay. This is kind of like still ugly, but well. Oh, okay, so actually no. Or else, yeah, this one. Okay. Okay, I kind of like it. I wonder if we should embark before we do this probe refactor. I wonder if we should embark on refactoring everything else to pending terminology, because it feels like it then everything should just fall into the place. Well, let's Kiwi merge. Empty drained key. Well, okay, let's see if this helps us with Kiwi merges razor tag. So let's say we have pending or an optional key. Does it help us? Okay, so well, I need to define constant here. Pending error pending. Try or else return or else continue. Well, I don't really like. What I don't like here is that although the shape of code exactly matches the try, I don't like that we kind of like include semantics of errors here. But okay, maybe this is fine. We write this explicitly. Catch errors which and then return error and then, well, yeah, that's ugly. I wish I could write just catch pending here to make sure that we kind of like catch specific variant here, or maybe even like, you know, right, catch and then, well, yeah, okay, so let's do this. And here we also say pending. Okay, yeah, and some of these like actually do use like this terminology. So let's do this pending. Next contender is going to be pending. Peak. Or else okay. Okay. Yeah. Okay. So I hope that we do like a quick rewrite of this like while loop, but it looks like to rewrite this while loop, we need to rewrite like this whole interface. But I think we achieved something. I think this error pending bank question mark key is really the essence of what we are doing here, because this is exactly the structural signature of the iterator, which might block. Okay. So I guess next time we'll probably try to just refactor everything to this uniform signature and see if this actually indeed simplifies the code somewhat across the stack. Yeah, sorry folks. I actually, like, a couple of episodes ago, I was like promising like, hey, like, just a couple of more episodes and we are finishing with query engine, but I sort of like working on this code. I think there is a room for improvement here. So probably, sorry folks, we are going to get stuck here for the foreseeable future, but that's why we're doing this. So as I've already told you, we have this targetable 1000x store, which is available in all of those fine cities in Amsterdam, Belgrade, Bengaluru, Cape Town, Lisbon, London, Milan, Munich, New York, Paris, Rio de Janeiro, San Francisco, and Vienna. And if you are in any of those cities and you are seeing this before, for December, then please join, and you might want to get some targetable content live. Okay, so see you folks in a week on next Thursday at 5 p.m. UTC, live on Twitch, or if that fails, I'm always there with you on YouTube. Goodbye.